All right, now let's go ahead and take a look at the last part of 5.3, which is our geometric series. So a couple terms that we need to go ahead and define. A geometric series is a mathematical expression for the sum of the terms of a geometric sequence. A geometric series can have a finite, meaning a defined number, or an infinite number of terms. So this is our equation that we have for our series. It looks worse than it is. Once we start plugging these numbers in, you're going to be fine. Let's take a look at example 6. All these terms are things that we've known before, right? So we have A1, which is our first term. We have R, which is our ratio. And then N, which is the number of terms that we have. And that should be also the same as what's up front here. All right, so let's look at, I'm going to move, well, I'll just write it down here. I have A1 equals 1, R equals 2, and I want to know the S6, first 6 terms. So N is going to be 6. So I'm going to take this and essentially just copy it down. So A1 is 1, and then minus, or excuse me, I'm already steering you astray here. 1 minus R, which is 2, and I'm going to raise that to the 6th power, right? And then I'm going to divide it by 1 minus R, which is 2. So when I start doing the math on this, right, 2 to the 6 is 64. So if I do 1 times 1 minus 64 over 1 minus 2 is going to be negative 1. 1 minus 64 is negative 63. And then times 1 just gives us negative 63 divided by negative 1. So I get an answer of just 63 on that one. All right, let's take a look at this next one. Find the sum of the first 8 terms. So N is equal to 8. What else does it tell us? I have a geometric sequence 192, 96, 48, 24. What I'm going to do is take a term and then divide it by what comes previous, and that will give me my ratio. So I can very easily see that 24 over 48 is equal to 1/2. 48 over 96, also 1/2. So I know my ratio, R, is going to be 1/2. And when I'm doing this on the calculator, it may be easier for me to put 0.5. It means the same thing. And then all I need to know is my first term, which is 192. So A1 equals 192. So I would have 192 times 1 minus R, which is 0.5, to the 8th power. And that's going to go over 1 minus R, which is 0.5. So I'm going to end up 1 minus 0.5 gives me another 0.5. So I have 0.5 in that denominator. When I take 0.5 to the 8th power and subtract it from 1, and then I multiply it by 192. So this will give me a teeny, teeny, tiny number. I subtract it from 1. It's pretty close to 1, so it just goes down a hair. So I should have 191.25 over 0.5. Don't forget to divide by that 0.5, and you'll end up with 382.5. So it's okay to have a decimal, especially if you're cutting things in half, because as you move on in that series, you're going to get smaller and smaller to the point where you're going to have fractions, and it's okay to have decimals. If it starts to get larger, be careful. It wouldn't add up to decimals unless you start with some decimals in there. All right, so that's that part. Let's go ahead and flip to the next page. Do example 8. We want to find S5 for the geometric series 2 plus 6 plus 18 and so forth. This S5 gives me the hint that I want 5 terms in my series added together. My first term, A1, is equal to 2. And then to find my ratio, I take 6 and divide it by 2, and my ratio is 3. So on to my equation. So I have 2 times 1 minus 3 to the 5th over 1 minus 3. And so I would have 1 minus 3, that's the easy part, gives me negative 2. So I'll have negative 2 on the bottom. And I see I have a 2 up here, so I'm not going to use that yet. 1 minus 3 to the 5th. This 2 is going to cancel out, but I'm still left with that negative in the denominator. So I'm just going to replace it with a 1, right, with a negative 1. And that 1 minus 3 to the 5th is going to give me the value of negative 242, because 3 to the 5th is going to give me 243. And then I take 1 and subtract that. I end up with negative 242 over negative 1. So that gives me just 242. And then example 9, when a worker earns a 4% raise each year, 4% is going to be 0.04. To find his or her salary in any given year, you multiply the salary from the year before by 1.04. Okay, so what that's doing is it's saying I want to keep 100% of my salary, but then I want to make sure I also get that 4% that I'm due each year. Okay, so that's what that 1.04 is doing. That's our ratio, 1.04. If you take a job with a starting annual salary of $40,000 and you earn 4% raise each year, how much money would you earn in your first 10 years? Well, there's my clue. I have 10 years that I'm recording, and my annual salary starting out is A1. That's $40,000 as my starting term. Don't get excited about the large number. This is accumulated over 10 years. This isn't counting any bills or taxes that you have to pay. So A1 is 40,000 times 1 minus R, which is 1.04, and we're going to raise that to the 10th power. And then we're going to divide that by 1 minus my R, which is 1.04. So in my denominator, I'm actually going to have a negative 0.04 because the difference there is just that 0.04, right? And then up top, when I do 1.04 to the 10th, subtract it from 1, which is going to give me a negative number, and then I'm going to multiply by 40,000. I get negative 19,209.77. And then I go ahead and divide it by negative 0.04. And I get the value of $480,244, which if I didn't get a raise each year, I would be at $400,000. So getting that 4% raise accumulates to about $80,000 over the course of that job. Okay, so those are the notes concluding 5.3. In the next video, we'll take a look at the monitoring progress.